All right, welcome everyone. Today is Wednesday, the 5th of November, 2025, and this is the Cluster API Office Hours meeting. We are a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which can basically be summarized as please treat everyone as you would expect to be treated, or explicitly so, please be kind to each other. And if you have a question, please raise your hand and I will call on you. So at the beginning of our meetings, we like to take an opportunity for new community members to introduce themselves. And if that sounds like something you would like to do, I will be quiet for about 10 seconds here. And please feel free to unmute and say hello to everyone. Okay. I don't think perhaps we don't have any new attendees today. So we will move on to our open proposal readouts. I see someone has been updating the propagating taints. The proposal has merged. Who would like to talk about this?
Yep, it's
Christian?
me. Just wanted to note we can remove the link at the top, or I'm going to remove it because it's not an open proposal anymore. And we just merged today due to lazy consensus, and I linked the tracking issue if someone wants to follow along. Yep, that's already it. Thanks.
Awesome. Great to hear. And I think you said you removed it from the open proposal list, right? Yeah. Okay, great. Awesome. Are there any other open proposals that people would like to report on? We have the independent worker topology versions and the external CA inserts. Okay. Not seeing any hands or people unmuting. So let us move on to our discussion topics then. Looks like we have some new CAPI releases. Who would like to speak about the new releases that are up? Do we have someone from the release team here?
I put it on the agenda, Mike, but I actually am. No, I don't know if the release team folks are here, and I don't have that much insight. So maybe Stefan or Fabrizio can summarize things.
Okay, we can all go through it here. So it looks like 1.12.0 beta is out. All right.
I think the quick summary is that we implemented two major features, in-place updates and chained upgrades that are like 95% done as of this beta. We did not introduce a new API version.
That's awesome. There's no need for V1 beta 3. Is that what you're saying?
Not yet. Yeah, I'll hand over to Fabrizio. Yes, maybe something more useful to say.
I think that the call for action here is we introduced two big features. In order to do so, we had to do deep changes in the code. We did a lot of work in order to ensure good quality. I don't know, machine deployment controller now has something like 2,000 tests, about 2K tests about rollout scenario, and before there was basically zero. And we did this for everything. So we were sort of obsessed about quality. But yeah, we did also a lot of changes. So the call for the community here is we really need support from the team to test that we did not introduce regression up around those changes. Especially because everyone is using CAP in a slightly different ways, and we did the best possible for what we know, but maybe we are missing something. So the more validation we have, the better it is. As usual, community makes this better.
Absolutely. Well said. And yeah, it's awesome to hear there's so much going into this release. That's really cool. Is there anything we should know about the 1.11 and 1.10 patch releases?
I think no, those were not big changes. Some version bump, and maybe I don't remember if there was a fix. So not much.
Yeah, they look fairly small. All
Yeah.
right, great. Yeah, that's awesome. And as always, big thank you to the release team. I think that's honestly one of the most inspiring things about this project to me is that like we have such a great release team, and I think it's a cool way for people to get involved and kind of you can see the project kind of moving forward and everything. So I think it's
And
definitely awesome.
if I may, a special kudo to Matt. Even if it is not in this release team, it is helping a lot again. So thank you, really appreciate. And if there is some way that we can help as a maintainer, please let us know.
Well said. Well said. All right. If there's no questions or comments about the latest releases, then we'll move on to Stefan's topic. So please, Stefan, take it away.
Alrighty. I'm not sure who was following the related caps in KK, but basically they merged the cap, I think, in the last few weeks, probably, where they were clarifying or redefining maybe how resource version should be used on objects. So the old definition was something like you can check if resource version is equal or not equal, but you cannot make further assumptions about like what the resource version means. This might be slightly wrong, but this is roughly what it comes down to. The new definition is that basically the resource version is a comparable integer, if I got it right. If you want to be 100% sure, just read the cap, it's not long. But basically it's comparable. You can, and have a util function where you can say like, okay, which resource version is higher. The only exception to that, based on what I wrote, is a non-conformant Kubernetes cluster. And if you have resources that are backed by an aggregated API server. So not our usual environment. So Kapi in general runs on, I would say, only Kubernetes conformant management clusters and also the resources that we use. Definitely the core Kapi resources, but based on our contracts, also the infrastructure resources are all based on CRDs. So if you look at the contracts, we say like, hey, you need an infra cluster CRD, you have to put this label on the CRD and a bunch of stuff like that. So in general, it's already not supported today to implement, let's say, an AWS machine with an aggregated API server instead of a CRD. So why is all of this important? So basically, what I defined here is that you can now define on resource version ordering, and you can do it for, I mean, it's not part of the cap, but Jordan wrote it on the PR afterwards, that this also applies to all historical versions of API server. So this was always the case, essentially. The reason why I want to start relying on that is because it allows controller optimizations. Basically, you can do a lot of stuff where instead of doing live calls all over the place. So let's make an example. Let's say one of our controllers is creating a machine. And to avoid creating the same machine again in the next reconcile, we have to make sure that we know that the machine is there, right? So that we don't just keep creating machines, even though we already created like 100 machines. There are two ways to solve this. One way is to do a live call. Basically, every time in the reconcile, do a full machine list, look at all the machines as they are right now, and then make your decision if you still need another machine or not. That is, for the scale targets that we want, too expensive. So what we're doing instead, already in a bunch of places, is that we're saying after we create a machine, wait until the cache is up to date. Basically, wait until the local client that is backed by a cache already saw the machine that we just created. And that will ensure that on the next reconcile of the same object, we also will see the machine. So basically, we're replacing live calls with waiting for something to show up in the cache. And the most convenient way to wait for something showing up in the cache is by comparing resource versions. So this is like a roughly high-level version of what I'm going for. So I have a PR almost ready that basically changes some of our stuff to use that. Under similar circumstances, something like this was possible in the past, but not always. I keep it there. So basically now this sort of optimization is like more widely applicable under the assumption that resource versions are comparable. I can share more via Slack or something. But what Fabrizio was saying, and I think he's right, is what I should clarify is two things. One thing, that cluster API is only supported on conformant Kubernetes clusters. And two, that essentially, of course, the core copy resources, but also the infra and control plane and bootstrap provided resources must all be implemented via CRDs. It's already sort of there. It's just not, I think, nowhere like explicitly spelled out. Maybe I have to check the book. I mean, it's definitely there in the contracts for all our resources. I think the statement that copy only works on conformant clusters might not be there, but I think it's a fair statement to make, because what can you rely on if the cluster is not conformant? Probably nothing. Yeah. Yeah. If there are questions, I can definitely go in more details. Intentionally kept it sort of high level.
Yeah, it sounds complicated. Like, I'm interested, but it also sounds complex. Does anybody have questions about what Stefan's talking about here, or about the CAP?
I can also definitely put link. I'm going to do it anyway. I'm going to link a PR in the agenda, which is the one I'm currently working on, that sort of shows how this assumption can be used to make optimizations.
Cool. Fabrizio, you've got your hand up.
Yep. So I think that we should make this explicit in the book. My suggestion is that we open a PR. I can take care of this.
Yeah,
that
that would be nice too.
that basically write this in a few places in the book. I think that it should go wherever we are documenting a contract, I guess. But
Yeah, the
we will.
contract thing might be already there. I mean, the provided contracts, there's already a lot of talk about CRDs. But yeah, I'm fine. Just do another round. Sounds good to me. Just make it more clear if it's missing somewhere or in other places
but
where it's not there yet.
The question is, who is the target for this clarification? I think that we are talking about providers.
Yeah, but I'm not sure, right? So there are 2 points. I think the point that you have to implement infra resources via CRDs, that's definitely providers. But if you look at the provider contracts, we already mentioned CRDs like 10 times. So I think the only thing is missing is one explicit sentence like, yes, you have to implement your infra resource as a CRD, because that exact sentence is not there yet. So that, I think that's okay. What I don't know is where like the sentence around copy only works on conformant Kubernetes cluster should go. But I'm fine with whatever place you find for that.
Okay. Let's make sure we have this in somewhere in the release, and then I will add where we talk about I don't know, support matrix, version support, stuff like that.
Sounds good. Just one note, because I'm on PTO once it actually happens. We have this release task for 112. I already started a comment with like, keep collecting release notes. And I added one bullet point for this topic in there as a reminder. Once we add the highlights, this will be like the highlights and this bullet point. At some point, we have to finalize the final.
Thank you for that.
Yeah, just FYI.
Lubomir, you got your hand up.
Sorry, I was not listening very closely because I was doing something else, but I wanted to understand better the statement that CAPI is only supported on conformant Kubernetes. I don't object to this particularly. I'm trying to understand, like for example, if I have a cluster that I run conformance tests on and the tests are not passing, are you saying that that's not a conformant cluster?
I think, yeah, maybe it's, yeah, the problem is it's tricky to do. So I think the statement that we only work on conformant clusters is relatively easy. The alternative to that is basically trying to define a subset of conformance that CAPI actually depends on, right? So like, let's say all the CRD stuff is important for us. I definitely agree. We don't depend on like all 350 conformance tests to be green. I'm just not sure what the alternative definition would be, what we actually need from a Kubernetes cluster, because I guess a non-conformant Kubernetes cluster is just entirely not defined how that looks like and what it even has, right?
I see. Yeah, I think making it clear that the entire conformance suite of features is not something that CAPI needs, and you mostly need a set of key features and you can enumerate them, right? The CRDs, whatever, and make it clear that this is not about CAPI really doesn't care about the majority of conformance features from case.
I think we can add a fuzzy sentence around that. I'm not sure if we can enumerate what we all depend on, right? Because we, of course, we depend on CRTs, we depend on leader election, we depend on config maps, secrets. The list is extremely long, I think, if I try to come up with it.
I see what you mean. Okay. But so the story is that you can still say that that's a good point, I guess. It's a bit fuzzy. You could say that there's a bunch of features that Capi doesn't need, but the majority of the interesting conformant features have to be uh, Capi compliant, you could say. Because yeah,
Just,
I don't want
yeah,
to I wouldn't
yeah.
put the whole conformance suite as
Yeah,
something that's actually required,
I just do a quick response and then let Joe answer. Sorry. I think I agree definitely general with the spirit of what you're saying. I'm just not sure how I define the subset because I mean, there are like probably like 100 API machinery caps, and like we depend on 70 of them because we use controller runtime and informers, right?
Yeah.
But how do I tell
That's
this to someone what we actually need? It has to be a fuzzy statement, right? In some way.
I think you could find the language for that.
Yeah.
I think it's doable. Thanks.
Yep. Yeah. Sounds good to me.
Yeah, Joe.
Yeah, I fall on the other side of that. I think that as a project, it is onerous to say anything less than you require a conformant cluster. I think it's on the user who does not have a conformant cluster to do the testing against their infrastructure and provide any, or at least request any changes that might be needed in order to address any non-conformant issues and functionality that they might need.
Okay, Fabrizio, did you have your hand up?
No, I agree. It should not be on us to. It should be on if someone wants to use a Kubernetes cluster, which is not conformant, it should be up to them to test Capi works. And I will not commit to implement anything to make Capi compliant to not conformant cluster.
Yeah,
I think it's simply out of scope.
I think that's probably the right language. We had this in a few other places. So we can write something like, like cluster API is tested and supported on fully conformant Kubernetes clusters. Outside of that, basically, we don't give any guarantees. If you have trouble, feel free to bring them up. We will decide on a case-by-case basis if it makes sense. Maybe there is something that still makes sense, even if it's not like a conformance problem. But definitely no guarantees that we just make everything work.
Yeah, I like this clarification. There could be some users, that explicitly want to use Capi with something that is not conformant with some crazy machinery. But if you clarify in the docs that it's only tested on conformance, that's, I think, clear enough.
Yeah.
Yeah, go ahead, Joe.
One example comes to mind that we had in the last, I don't know, years that I'm aware of. I'm not even sure if it's part of conformance or not, but basically we had a report that was saying like, hey, in beta 2, you use two column names and they're the same. Regular Kubernetes absolutely does not care. KCP, not our KCP, has a problem with it. And we basically said like, yeah, sorry. I mean, Kubernetes doesn't have a problem. There are no bugs there. You have to open the issue for KCP to see why KCP makes a difference compared to a regular Kubernetes API server. And I think all of this stuff will potentially fall into similar buckets if additional points are brought up. I mean, of course, if something is reasonable, we can always talk about changes, right? It's just.
Yeah, the conformance suite used to have a specific test, I believe, from the SIG apps bucket that requires two nodes to run. So it's kind of a bit confusing, maybe, that if you say that, hey, it has to be conformant, but Does it mean that CAPI can only deploy pairs of two machines? Like it's so, you should probably clarify, like it's about features and yeah.
I think the important thing here too is to talk, like in the original statement, talking about support as well, right? Like what do we support as a community? And I think that's where I really like turning it around like this, saying that cluster API is developed and tested on conformant clusters. That's the expectation of the people making this software. If you come up with a situation that's outside of that conformance, or that highlights an area that cluster API is out of conformance or something, then we would want users to report that back to us. We would hope they would open issues, they would, and we can manage it that way. Because I think, yeah, like I had a similar thought as Lubomir when I heard the first statement, just it sounded really fuzzy, but I like where we're heading towards with this.
Well, also, if there are users who insist on making changes on CAPI that are not really in line with the conformance agreement of the project, then those people should probably not even open issues, because how can the maintainer team find priority for these types of?
Exactly. Yeah.
So I would like the language where we say, like, we cannot prioritize anything non-conformant. And people should know that they should probably not open even tickets for that. As a maintainer, that's my 2 cents.
I would say, Fabrizio, thanks for taking it over. We do a bit of polishing on the PR until everyone is happy. But I think we got a lot of good input.
Yeah, great.
Yeah, and
great
starting with the next minor release, I would start relying on like the resource version thing, which should be fine under the assumption of what we just said, that we only run on conformance stuff, and that providers here provide resources have to be implemented with CRDs.
All right. Any other questions or comments about that? All right. Stefan, thank you for bringing that up, and thanks everybody for the discussion. I think that was good, good comments there. Okay. So I added a topic to kind of come back to something that I brought up, I think last week or the week before, about, kind of the upgrade process and everything. And, I wanted to bring this up just to help bring the discussion back up. And I think this is the kind of thing where as cluster API gets better and better, I think it's the kind of thing that we're going to have to consider more and more, or maybe not consider, but I think maybe like our community needs to come to some sort of position around this and whatnot. But um, for review, as we're building the Carpenter Cluster API provider, something that we're running into, and this was highlighted by the bug that we ran into on the cluster autoscaler recently, is that we're starting to see more tools that want to get in the middle of like the node upgrade life cycle, right? And so I got a couple slide decks here just to demonstrate, to kind of illustrate some of the issues we're talking about. So the original bug we found was something kind of related to this, and I'll go through the sequence diagram after. I know this diagram doesn't always make it clear, but like, if we have a normal cluster API setup where we have a machine deployment, it's got one machine that's become a node, and we start to go into an upgrade scenario. For something like the cluster autoscaler that's relying on the number of replicas here, the state of the world starts to become confusing at this point, because it sees multiple nodes that belong to the same, node group essentially, but it only sees one replica here. And what ends up happening in the cluster autoscaler is that the cluster autoscaler will see an old node that's probably in the middle of an upgrade. Perhaps the user is waiting on a workload to be removed from this, and it will see the new node as well. And it thinks that this old node should be removed because it's way too old or underutilized. And so the autoscaler attempts to decrement the number of replicas here. And at this point, things become really confusing, because if this old machine can't be removed for some reason, then the deployment controller will satisfy the request by removing this one, which is a new machine that might have workloads going to it. And so if if we go to the issue that we opened about this, it becomes a little clearer when we look at the sequence diagram for how all this works. So the user begins upgrading their machine deployment by changing the info ref, right? And so this kicks off cluster API to do all sorts of, changes to start doing the updating, right? Now we get down to this point here. For any reason, workloads are not moved to new machines. This is where the problem comes in. If a user has done something, maybe there's a pod disruption budget in place that keeps the old node around. Now the cluster autoscaler observes the old unneeded nodes and it wants to reduce that replica count, which causes this change to come, and then cluster API ultimately removes the wrong machine. So this is a bug, and the way that we've chosen to fix it in the cluster autoscaler is by not allowing the autoscaler to downscale machine deployments that are undergoing this type of upgrade. But something that I wanted to highlight was where we're going with a tool like Carpenter. So this is kind of looking at what an example of like a microcosm of what one node in a cluster that has cluster API and Carpenter might look like, right? So we have a machine deployment that ultimately resolves to a machine and a node. And from the cluster or from the Carpenter side, we have something called a node claim that is also looking at that node. And in Carpenter's parlance, these aren't the same as the cluster API objects, but Carpenter also has what's called a node pool and a node class. And this is how it's structuring, groups of nodes within its control. And so what can happen is if a user updates the machine deployment, that would trigger an update of the node. But in Carpenter, if they change the node class, which could be, in cluster API, it might be viewed as similar as changing the infrastructure reference, pointing to a new machine type or something. This would also trigger a redeployment of the node. And then what can end up happening is the way Carpenter wants to do its update starts to become confusing to cluster API, because what Carpenter wants to do is mark a machine as going away and then manipulate the replicas so that it can, bring new machines in, right? It wants to delete the old one and then bring a new one in, and the new one will be upgraded. So this presents kind of like a challenge from the perspective of someone who wants to write a tool like Carpenter and have it work with Cluster API, for example. Because if we want Carpenter to sit on top of Cluster API, now we really have to think about our use cases and are we going to be controlling all of our upgrades from the machine deployment? Or are we going to allow Carpenter to control updates from the node class? And what does that mean for how we develop this in the future? Because one of the big features of Carpenter is the notion of what's called drift. So Carpenter can detect when the node configuration has drifted from the node class configuration. And then it wants to try to upgrade those nodes. And so I think as we think about Cluster API and Carpenter and probably the tools that will come after Carpenter, I think this is an interesting question for us to consider. How do we advise our users to say, okay, well, if you're doing these type of upgrade scenarios, if you have another tool that's running the upgrade for you, then maybe you don't want to use a machine deployment. Maybe you'd prefer to use a different, maybe you just want to use a machine set or something. And likewise, if the user is telling you well, I want to use Carpenter to do upgrades because Carpenter handles all these things, then this is a scenario where they wouldn't want to use a machine deployment. They'd want to be using the machine set, or maybe they should never touch the machine deployment. And then, kind of conversely, if a user is used to using the machine deployment to do all this stuff, then we're going to want to advise them, okay, in Carpenter, turn off the upgrading mechanisms. You don't ever want to use that. You want to let Cluster API do that. So I see I've spoken long enough to excite something within Stefan. So please, Stefan.
Yeah, definitely 2 points. So 1 point, machine deployment is not necessarily always the source of truth within Cluster API for how machines should look like. there's also the variant where you use cluster class and cluster spec topology and stuff, where basically this is even one layer higher. And basically you change something cluster spec topology, and then core copy controllers are rolling this out via machine deployment. So just saying, like, there's this overlap of functionality, and then there's like one level higher where it's like even more.
There's even another level up. I get what you're
Yeah.
saying. Yeah.
And I'm not sure if you mentioned that at the end or not, but you were saying one feature of Carbon is the drift detection, which is basically like the same feature as machine deployment, right? You see like there's a difference, and then you walk through the rollout. But I think there's also like this other feature of Carbon, like this other big one, where basically it's like, okay, it looks at what you need, and then it figures out like, oh, you need exactly like this configuration, VMs in that size, etc., etc. What I'm wondering is also if like a good way for like let's say coexistence could be that we basically, I mean, there are probably multiple modes that we maybe want to make this work, but maybe one interesting mode could be that basically Carpenter would maybe not do the drift detection. So sorry, let me rephrase. Carpenter would not worry about the details of how we get to a certain target state, but basically Carpenter would act through cluster API to get to where it wants to go. So if Carpenter is saying I need like, I don't know, 3 small VMs, 5 big VMs, whatever, then it could basically modify the machine deployment or cluster spec topology to let cluster API, worry about the rollout details of like all the features that we have in there, because there's a significant amount of stuff in there. While it will still be able to do the part that is also super important, that basically Carpenter decides like the shape of the cluster essentially, right? I mean, that's a big feature of Carpenter as well, that based on all the information Carpenter has, that it can optimize the shape of the cluster to optimize for the workloads that are running on there. Yeah, that's my initial take.
I think you're right about the cluster class. That's something that I think we still need to figure out. How does that work with cluster autoscaler and Carpenter and whatnot? And on your second point, yeah, like this is like I would love to figure out a way to get to a point. And I think we got to this point with the cluster autoscaler where we talked about there should be a mode to operate the autoscaler where you turn off some of its knowledge. So it doesn't think it's controlling everything. It's running on top of something else that's controlling everything. And I think like finding that mode in Carpenter might be a good way to think about this as well. But that is also going to be difficult because Carpenter wants to try to control every node that it has. And at some level, I see what you're saying. Like I've been thinking about this a lot. Like, could we have the core of Carpenter say, I've noticed a drift, and then the cluster API component is the one that applies the drift. Is there some way that we could get Carpenter to operate like that? I think it's an interesting thought. I'm not sure that it's possible, but yeah. Thank you, Stefan. I think Lubomir, you were next.
Yeah. So I was monitoring the last bug that you put here in the agenda as well about the cluster autoscaler. I was quietly listening to that discussion particularly. And also now I see this presentation from you about Carpenter. It seems to me like we are lacking some sort of a mechanism, whether that's a contract between all the tools that work with CAPI in this case, like the cluster autoscaler and the Carpenter. But it seems like we're missing some sort of a mutex. That's at least my understanding. Maybe it could be an opt-in mutex, or there could be multiple mutex modes. What I'm talking about is the tools have to agree between each other what one tool can touch and what it cannot touch. And that's actually the bug here. And as a user, maybe I know folks here have worked with customers in big companies, but I'm curious, do we even have people who care about the autoscaler scenario during an upgrade? That's not very clear to me, because if it was up to me, I will completely block the autoscaler during when CAP is doing its business with the scale up and down of the machines, because this enters the land of crazy bugs that you don't know how to fix, and corner cases, drifts, and so on. So if you implemented some sort of mutex mechanism, the same way in the API server, multiple client requests cannot touch the same object. That's by design in the system. I would expect cluster API and the ecosystem around it to also implement mutexes somehow. They could be opt-in. Maybe you have a customer that wants to run this craziness at the same time, but I would not advise it. And maybe there could be opt-in methods to avoid this.
Yeah. No, good, thank you, Lubomir. Good suggestion and good questions too. So, to one of your questions there, do we have people who care about the autoscaler behaving during an upgrade? Yes, we absolutely do. And I can tell you for a fact, there are some very big Kubernetes customers in the ecosystem who use this behavior regularly, and they depend on this behavior for how they do their upgrades. Now, that said, it's one of those things where this bug that that I linked here, and that Fabrizio and Stefan helped me out with a ton in terms of figuring out how to resolve it. That bug was discovered because this customer of ours, of Red Hat's, kind of came into this problem, right? And through understanding that, I've connected with a lot of other users, and I've also investigated how this works on other clouds. And so I know that other clouds, and I'm not trying to point fingers and name names, but one of the investigations I looked into was EKS, because I was curious how this works on EKS. EKS handles it in a different way with respect to the cluster autoscaler, and they handle it in a way that allows the user to continue running the autoscaler during upgrades and whatnot. And so I know this is a feature that there are users who are interacting with. It's an interesting topic of discussion, I guess. And to the point of the mutex, yeah, that's something I'll have to think about. Like, how could we arrange that between the other processes and whatnot? I think Fabrizio, you were next. You're muted still, Fabrizio.
Oh, sorry. So I think that those are all good points. I agree that there is not a clean contract, but I think that what we have today is a contract that the autoscalers should scale. It turned out that the autoscaler is not only scaling, it's draining, now it also want to update. And so I think that we first have to decide, because from one side we have user that ask cluster API, hey, manage this cluster, hey, update in this order, hey, I want this release, this version across everything, okay? Or I want to perform update in place, or I want to perform chained upgrade. So things, let me say, from one side we have I want to manage to have sophisticated logic when we choose the image to apply to a cluster, or so we have a request that ask Capi to become more sophisticated and control more. Okay, and it is from one side. Okay, from the other side, I understand autoscaler is an issue, but we have to decide to take foundational decision, like when you do an update in Capi, the driving factor is the availability of machines. Okay, and the availability of machines is again a user requirement. It is the user that define, I want max unavailable, max one machine, max unavailable, or max surge 3. Okay, it's user defining the rule of the game. Okay, what does it mean have the autoscaler on top of those rule of the games? Because those are conflicting requirements. Or, I don't know, in cluster API, we are draining, and we drain according to drain rules, which are defined by user. And if they fair draining also to an autoscaler, there is a conflict. Drain will happen in a different way. So I think that it goes back to, we have to go back one step and think about, okay, what is the responsibility or the advantage of one tool and the responsibility of the advantage of the other? Because I understand user, those are cluster API gives some, is a tool that gives some benefit to the user, autoscaler gives some others, customer gives some others. But there are also overlap, and we have to figure it out how to sort them. That's the key point. And it goes and it goes really deep. It is not only managing a replica, it is all the chain of feature of the two tools. And this is what we discover with that issue, is that it's not just adding, going up or down. It is only about when workload get moved, and unfortunately, user can have a say on workload that moved. So it is really complex. I will not limit the discussion to who managed the replica number, because there is a lot.
Yeah, no, thank you, Fabrizio. And like I'm not trying to upset the apple cart or anything here. Like I want kind of the same thing that Stefan is talking about in chat here. I want to figure out how do we leverage kind of the best of both projects, or how do we make this work the best for our users, or even if that means just getting out of the way and letting the users kind of do what they want to, how do we make it the best for them? And the deeper I get into issues with cluster API, or the deeper I get into understanding cluster API, the way that I'm talking with people about it is, for me, as a cluster API user, like I'm starting to view cluster API as like the cloud provider, right? Like normally, if I were running a cluster and I had it on AWS and I was using an AWS CCM and a CSI and whatnot, and I was just maybe running Carpenter directly on my cluster, and it's just making nodes in AWS. Like AWS is my cloud provider. But when I start to run a cluster that has cluster API in it, and then I'm going to run the autoscaler on top of it, or Carpenter on top of it, or anything on top of it. Like for me, the mental model I'm building is now the cluster is my cloud provider. I'm abstracted away from the real cloud provider. And so in some ways, the cluster APIs, they become my new, EC2 interface, or my, vCenter interface, or whatever you want to look at it like. And so for me, at some level, when I'm looking at these tools, that's some of the way that I'm looking at how they interact with the lower levels. Who is next? I think Stefan.
I think I have a similar but a bit different point of view here. So the way I think I'm thinking about it, or maybe it could work, I don't know, is to see this a bit like, like different layers. So basically, cluster API today, let's ignore Carpenter autoscaler for a moment. Cluster API today is you can basically say like, I want this cluster, I want that many machine deployments. Doesn't really matter if you do it with cluster class or not, but basically you define in cluster API, this is how the cluster should look like. And then cluster API takes care of creating machines, deleting machines, training machines, whatever is necessary to make it happen, right? And what I think is that essentially, like today, a user basically can manually modify the desired state, modify the cluster, modify the machine deployments, whatever. You could also have, of course, have some sort of autopilot, autoscaler thing sitting on top of cluster API and say like, hey, this cluster looks like this. I'm getting this and that signal from wherever, right? From the worker cluster, from looking at nodes, looking at pods, whatever. I get that signal, and I basically realize, okay, the desired state is not actually the right desired state anymore. So what autoscaler and Carpenter should then do in this model is basically they should modify cluster and machine deployments and whatever they have to do on that level. And then essentially leave it to cluster API to deal with the lower levels, like creating, deleting machines, draining machines, all of that stuff. But I should not act like on the highest level and on the lowest level at the same time, in my opinion. They should just sit on top of cluster API and tell cluster API how the cluster should look like. And then cluster API's job is to make that cluster look like that. And there's just one big difference between how cluster API, the feature set of or the scope of cluster API compared to other cloud providers from a cluster autoscaler perspective is that cluster API is more powerful, right? Because cluster API can take care of drains and stuff. It's not that cluster autoscaler also has to take care of that, because that's how it is in other clouds. So I think that's one point. Essentially, maybe this is a mode how it can work. That on one side you have CAPI with its scope. Then you have autoscaler tools that are looking at the state of the world, figure out how cluster should look like, tell cluster API how it should look like, and then cluster API just makes it happen. And then just one excursion to the max search, max unavailable versus autoscaler thing. I think there's a bit of a philosophy difference there. One is essentially the current one in CAPI, which is to say like, oh, I have max search, max unavailable, and I'm setting my cluster size in a certain way. And then essentially cluster API preserves that, let's say, that static information, right? We want exactly that replicas, we want them unavailable, whatever. And then we go exactly like that through rollouts, upgrades, everything that has to happen. And then I think the autoscaler mindset is different in that sense, that essentially it does not really care about availability and that sort of stuff at all. What it cares about is, I'm not sure if this is like maybe the only thing that's actually relevant, but it's definitely a large part of what is relevant. It cares about that every single pod that a user wants to run actually has a space to run. And the thing, if you look at it from that perspective, and in that mode, essentially, I'm not sure if available and that sort of stuff is even important, because if the sole goal of a workload cluster is to run pods, and the autoscaler can ensure that the right number of machines in the right size and shape and whatever is available to run all the pods that have to run, then I'm not sure if once you're running in that mode, it is still important to respect max search and max unavailable, because the whole point of max search and max unavailable is just to have enough nodes that the pods can run. If autoscaler can do that, only looking at pods and nodes and changing machine deployment and cluster specs, why should it still care about max search? But just take that as like an initial take.
No, I love it, Stefan. And in fact, like what this is causing me to think is that like what I would like, what something that I would like to do, or I would like to see come out of all this is like, I think probably I'll start working on some sort of documentation that could be like, I think we should have advice to people who are running things like Cluster Autoscaler and Carpenter to know how to set these things, right? Because you like what you're saying about max surge and max unavailable is like, yeah, it makes a lot of sense, right? But like when we're debugging these things and looking at the way users are using these, like one of the things that I'm kind of getting to the point of is like, if you're running with the cluster autoscaler, why would you ever run anything less than max surge 100%? Like you should always just let it make whatever it thinks it's going to make. Don't try to, don't try to reduce the surge or whatever. But this is where users run into problems. And so I think having a document that like discussed all these so that we could point users at it and say, okay, if you're configuring cluster autoscaler with cluster API, these are some things you should know about. Because like one of the things that I'm fielding from users is they say, I use cluster autoscaler with cluster API or I use cluster autoscaler with EKS and it behaves this way. And then I use it with cluster API and it behaves this other way. Why is that? And it's like, okay, well, because they're different platforms, they behave in different ways. They have different, exactly what you're talking about here. There's different mindsets, different goals. So, yeah, I think maybe that's something that I'm going to take away from this. Fabrizio, please.
Yeah, definitely. I think we should go down this path to find where is the friction, and pick the best of the two tools. Just one point. I think that is not correct to compare Cluster API with a cloud platform. It is more correct, at least in my opinion, it will help in the discussion if you compare Cluster API with a managed Kubernetes offering in one platform. So AKS, GKE, they have their own opinion on how machine, whatever should happen in the cluster. And so basically like Carpenter or Cluster Autoscaler at the end get an agreement with those managed Kubernetes offering, we should get an agreement with CAPI. I think that's the difference. You're not dealing with bare machine or single machine, or at least you can also do this in Cluster API, but you will lose, I don't know, 80-90% of the good thing that Cluster API offers.
Yeah.
So
No,
I will not recommend to go down this path. I will prefer that we try to find where are the friction points. It is only about max surge and mean available. Okay, let's think about to disable them if you are using autoscaler or whatever solution will come up. But I think that the main point is that for Cluster API, the cluster is a entity and it try to manage it because this is what it exists for. So it's not really dealing with single node or standalone node. It try to manage the entity.
Yeah, no, I think that's very astute, Fabrizio, and I absolutely agree with you. I think a more accurate comparison is to say that it's like operating a managed Kubernetes service. Like I use cloud provider in the place as a stand-in when I talk about abstractions for like cluster autoscaler and Carpenter, because I think like when like you're right, you're not just making infrastructure or making things the same way that those actual services would be, or those actual cloud providers would be. But in my mind, it's like a useful separator, right? It's like in many ways, Cluster API does become the cloud provider. And especially with Carpenter doesn't know what the cloud provider has when it's running in Cluster API. It only knows what you've told Cluster API to allow it to have, right? The same way that Cluster Autoscaler, like only machine deployments that I choose participate in the Cluster Autoscaler. So in some ways, the Cluster Autoscaler only knows how to make what I give it, or Carpenter only knows how to make what I've shown it in the inventory. Whereas if I hooked Carpenter up directly to AWS, it would just search through all the inventory. It would search through every region, every instance type, and that's how it would know. So from an informational point of view, Cluster API is acting in a similar manner. But I think I agree with you, and I'll probably adjust my language in the future because I think it is a little more accurate for what we're talking about here.
Yeah, don't worry. Cloud provider is also how it is called in autoscaler, so we know where this comes from. So it is just a clarification, just to make everyone thinking in the right direction.
Yeah, agreed. And I do want to address this discussion that's going on in the chat here because I think Igor brought up a good point here. Um, Igor, yes, like what if Carpenter acted on machines directly, skipping the machine deployment, skipping machine set, similar to how it does with it. Like, yes, that is an alternate design. And we documented that design in the Carpenter repository. So one of the alternate methods that I was thinking about for how we should make Carpenter Cluster API is what if we had Carpenter just looking at infrastructure machine templates so that that's how it knew what was available, and then it would just make what we called orphan machines, or maybe it would make a thin machine set around a single machine so that it could make whatever it could see in the cluster. And then I think, yeah, some of these problems that we're having would be different. We wouldn't see them the same way because we would allow Carpenter to use Cluster API more like it wants to, right? Where it's individually addressing machines and everything. But when we discussed that design, and this, I remember we had this probably discussion a year and a half ago, like there was a notion in the community that what we wanted to see was, there's a lot of work that goes into the machine deployment. There's a lot of cool features in the machine deployment. And could we preserve those cool features? Could we preserve that usability and allow users to have kind of the best of both worlds? They could get Carpenter and they could get these features that the machine deployment has. Now that we've done it and we've been practicing it and using it, we're learning more about this. And so like I'm starting to get into this mindset, and I think these discussions are very helpful for me. Is like, yeah, again, going back to what Stefan said, like, how do we get the best of both worlds? How do we make it so the user could use both these things and kind of choose the best features from them and allow them to work? And then, to what Fabrizio said, when we find friction between those tools, how can we reduce that friction and make it so that it's just easier, for users to manipulate these things? Stefan, please.
Yeah, just to mention one point about machine deployments that probably almost nobody's aware, and there were times at which I would have just preferred to delete the feature, but just to mention it. So machine deployment was largely copied from deployments, and one feature that we got out of that is that I'm not sure if that was the spirit of the feature, but that's how I understand that it works. It's basically that on a machine deployment, you can set a spec pause to true. And what that means is, it's not that the machine deployment is entirely paused. It just means that while a machine deployment is doing a rollout, it will keep the same proportions of old and new machines and not further progress with the rollout. What it essentially means is that once you are, let's say, like at 30% of your rollout, you can pause it. I don't know, like canary, right? You have like some config change. You want to do 5%, 10%, 15%, see if everything works, and then this sort of stuff, right? So you can pause a machine deployment in that way. You can still scale up and down the machine deployment. It will create and delete machines to stay on that percentage, essentially, and then you can move on. And I think this sort of stuff, for example, is something that, as far as I know, doesn't exist in Autoscaler, right? That concept of you want to get from, that would be more like towards Carpenter, because Autoscaler in general, I think, does not worry about that sort of rollout stuff.
Right.
Detection. Yeah, but it would be nice if you would be able to combine those sort of features, right? That essentially Capi can still do this sort of stuff while tools like Carpenter Autoscaler can still do their stuff in the sense of tell us what the right desired shape is and tell us that we should move in that direction. But you still have the features to say like, oh, but don't move that quickly in that direction or whatever.
Right. Yeah. This is great. This is great feedback, and it's really a great discussion. And like the difficult part now is going to be going back to like, cluster autoscaler and Carpenter communities and kind of figure out where do we make this line. But again, I appreciate everybody's input here. Thank you so much. We're pretty much at the end of the meeting at this point. Does anybody have, oh, you know what? There was one more topic though that I did want to get to. KubeCon is next week. Some of us will be there. I'm guessing next week we'll probably not have this meeting since KubeCon will be happening. If there's any sessions folks would like to promote, feel free to link them in here. Unfortunately, I thought of this too late, so I didn't have time to go back and kind of plumb the schedule. I guess the question is, do we want to resume meetings then on the 19th, the week after KubeCon, or do we want to give folks a week off after KubeCon and come back on the 26th?
I think we have to resume because we are getting near release. So maybe
Okay.
it's better to get together. Even we can try to keep the meeting short, but I don't think the skipping is.
Cool. Sounds good. And yes, Joel has a shameless self plug here. He has a session at the Maintainers Summit this Sunday about the Kubernetes linter. I don't remember what the A stands for. Kubernetes API linter. Yes. So yeah, go check that out if you're into APIs. All right. I think that's the end of our meeting. Hope to see some of you next week in Atlanta. And for those I don't, I'll be thinking about you. All right. Have a good one, everyone.